Improving automatic summarization for browsing long-form spoken dialogue. Every day we are surrounded by various forms of long-form spoken dialogue. Over the past decade, listening to long-form audio content has seen a significant rise across multiple forms of media, including online lectures, podcasts, and more. Although such media has seen a meteoric rise in volume, the way users consume this content has largely remained the same, listening auditorily. These are all rich sources of information. However, they can be time-consuming to listen to and difficult for listeners to extract salient information from efficiently. Much research has already explored various avenues for improving the efficiency through which users consume long-form audio. One key area is that of automatic summarization of such long-form audio. However, utilizing language models to summarize long-form audio content poses several challenges. Moreover, resulting summaries typically have a static level of detail which may not be suitable for all users. To tackle this latter issue, recent research has shown hierarchical summarization solutions to be effective in providing users multiple levels of detail in their generated summaries. However, even these existing solutions are far from perfect. Today we tackle improving solutions to this problem on two fronts. First, with a regime of model-agnostic language post-processing techniques to improve the quality of automatic model-generated summaries across three key metrics: readability, accuracy, and adequacy. Second, we explore how better speech browsing interfaces utilizing these improved summaries can provide real value to users. Before we dive into the regime of post-processing techniques we are proposing, let's first contextualize the existing challenges and concerns with model-generated summaries. First, the issue of readability. Automatic speech recognition systems may incorrectly split sentences, causing fragmented language which is difficult to understand. These incorrect fragmentations can confuse summarization models with ambiguous context, as seen in the example. Often, mistakes in the ASR transcription process can compound through a language summarization pipeline, ultimately yielding unreadable results. In this same example, when not fragmented, we see another issue arise, one of accuracy. ASR transcriptions may incorrectly transcribe homophones, which are then fed to models which may cause further hallucinations. As we've seen, inputting inaccurate text to language models can cause readability and accuracy issues, but providing unrelated or contradictory text can cause a third critical problem, one of adequacy. Inadequate summaries fail to capture important meaning of underlying content, or only captures a subset, causing users to potentially miss critical information. Now that we've discussed the challenges faced by automatic summarization solutions, we can dive into the model-agnostic post-processing regime we propose to improve the summaries generated by these hierarchical approaches. Here we see a high-level representation of our proposed process. First, we input audio into a standard state-of-the-art ASR system which provides automatic transcription, speaker diarization, and predicted punctuation. We take that base and we tackle the problem of adequacy through entailment clustering to improve cohesion. Next, we perform co-reference imputation to resolve ambiguous references in the text, as well as running grammar correction to improve the overall readability. We conclude with hallucination resolution during summarization to improve the accuracy of the summaries, and then this process is repeated for each recursive summarization level to achieve a hierarchy of summaries at different levels of detail. Now let's take a closer look at these processing optimizations. Problems with adequacy arise when summaries miss critical information. Conversations are not linear, and often topics are mentioned and then revisited much later in a discussion or presentation. We tackle this problem by clustering each sentence based on contradiction probability to determine a new cluster, and an entailment similarity score to place in an existing cluster. We then take all possible orderings of these clusters with the new candidate sentence, and select the one with the lowest contradiction probability before finally adding said sentence into a given cluster in the selected ordering, therefore improving the overall temporal dialogue cohesion of the input text to the language model. Unlike written prose, conversations often contain ambiguous references which, when recursively inputted into models, causes compounding readability issues. To combat this, we eliminate vague pronoun references at each pass with named entities identified in a set context window. This may create better clarity, but may also induce grammatical errors due to imperfect insertions. Thus, we finish this phase with a grammar correction step using a T5-based grammar rewriter trained on a fluency corpus. Together, this improves the readability of resulting summaries. Finally, to achieve better accuracy, we introduce hallucination resolution, where a guided beam search provides a group of candidate summaries which are then scored using a quality metric which combines Rouge2 scores with syntax quality scores. We identify hallucinations, terms which are not present in the original source text, and utilizing existing word knowledge systems discern good hallucinations from bad ones, pruning all summary candidates which contain bad entities. We then resummarize while blocking these identified bad entities and retaining good candidates, before finally selecting the best candidate out of this pool based on a Rouge plus entity intersection metric. Our system interface focuses on 5 key areas: user intent, user navigation, transparency of the underlying models, error correction that enables users to regain comprehension when errors in summaries arise, and finally, explainability with respect to how these summaries are generated. Here we see how information is presented in the interface. On the left side, the shortest level summaries have been concatenated into a readable article. We also see a total information displayed metric, which represents the total amount of information contained in the material that has been exposed to the user at this point. Clicking any segment on the left side populates the right view, which provides a summary quality estimate for the selected segment, as well as an information gain metric, which represents how much additional information users can gain by diving deeper and reading the initial summary and/or original transcript. Finally, we see that an audio player, which can play the raw original audio for a given segment, is present on the right side for users to utilize when erroneous text has been provided or they need additional information. A key part of improving explainability and transparency while expanding user agency is the idea of providing information sent to users through heuristics. By presenting short summaries start to finish in a linear fashion, users can read short summaries to get a better idea of a speaker's conversational flow. By selecting a given summary segment, users are provided information sent in the form of an estimate of that segment's quality, which may inform whether they should trust it or spend more time reading a more detailed summary or listening to the original audio. Further information is provided through an estimated information gain to help users determine whether that additional time investment would be fruitful. Now let's dive into the results of both the model agnostic processing optimizations as well as the accompanying system interface. To determine the summarization quality improvement, we performed 2 separate evaluations. An annotation study was performed where annotators were instructed to assess 791 segment summary pairs for readability, accuracy, and adequacy. We saw a marked improvement in all 3 areas. An automatic evaluation was also performed on the improved summary pipeline against gold standard reference summaries, which found improvements especially in longer sequences. At the short summary, least detailed hierarchical level, we saw a pronounced improvement as our pipeline's optimizations clearly addressed speech errors, preventing them from propagating. To evaluate the interface and system as a whole, we performed a quantitative user study where we recruited 12 participants and ran 2 experiments. The first procedure was a recall task where participants were evaluated on their recall of material when consuming content through the system interface versus consuming it traditionally by listening to unprocessed source media. The second procedure was an information foraging task where participants were asked to extract information from media through the system versus through an unprocessed audio media. We found the average recall and foraging accuracy scores to be slightly better for participants using our system versus listening to audio, though it was not statistically significant. However, the average duration participants took to complete these tasks was significant, with a 47% and 46% decrease in task duration, respectively. Lastly, we go over qualitative user feedback. One participant stated, "The summary quality metric was useful to help me decide whether to invest time expanding a summary to read further." Another subject said, "I could glean 80% of the information from the left side view," while another stated, "When transcription was incorrect, the summaries were incorrect and I had to use the audio." Another subject said, "It structures information well by length and complexity." And finally, one stated, "After a few iterations, I began to trust the summaries and quality indicators more and could work faster." So in conclusion, our system affords accessibility, user intent, transparency, user control, and explainability by merging a model-agnostic processing regime with an improved hierarchical system interface to achieve more efficient consumption of long-form spoken dialogue. Thank you for listening.